algebra students, Mr. Lawrence here with a Unit 2 review. All right, let's get down to it. Our test is coming up quickly. It's on Tuesday. So let me see, am I in writing mode? I am. All right, first of all, we have to know how to solve inequalities. Now remember, we like to listen to Saddam. Of course, if we're doing a quadratic, we might listen to Sad Me, right? Because we have to undo the exponent, but we're going to follow this order. So in this problem, I'm going to subtract 5 first. And when I do so, I'm going to get a negative 2x is less than or equal to 12. Now I'm going to divide by a negative 2. Whoop, 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 whoop. There should be warning bells going off in your head. I just divided by a negative. And I've got negative 6. If I'd like to graph it, I'm going to need negative 6 on the number line. It's going to be a closed point because the 6 is equal, right? There's an equal there. Sorry. And I need numbers greater than or equal to negative 6. Wouldn't they be to the right of negative 6? And there we go. All right, number 2. First thing I'm going to do is I'm going to get rid of this 3, make the problem a little less complicated. And so I shall have 3/5 x greater than 1/4 x minus 2. Now I'm going to multiply to get rid of my fractions. It looks like I should be able to multiply by 20. That's the number that will get rid of both fractions. I'll do 20 over 1. Remember over here, I'm distributing. And I'm distributing 20, not the simplified version of 20. So 5 is going to go into 5 1. It's going to go into 24 times. Now I have to do 4 times 3, which is going to be 12, and then there's going to be an x, right? I have to multiply the 4 times the 3. All right, over here, just to make sure I don't make a silly mistake, I'm going to do 20 times negative 2 and get negative 40. And then here I'm going to do 20 over 1 and I'm going to divide, get 5, and then 5 times 1 is 5 times x, 5x. All right, I don't like that there's x's on both sides, so I'm going to take this x away, these 5 x's. I have to do it to both sides. And that will leave me with 7x greater than negative 40. Now, I've got to divide by 7. Be careful here. We're going to divide by 7. Now, did I divide by a negative? No, I did not. And that's why you don't hear the warning bells going off. The inequality will not flip because I didn't divide by a negative. I divided into a negative. It's not the same situation. If I want to go mixed number on that, looks like it's going to be negative 5 and 5/7. So if I make a number line, I can locate, negative 5 would be here, negative 6 might be there, negative 5 and 5/7 would be pretty close to negative 6. And I will have an open point. And I need numbers greater, so I will shade to where the numbers are larger than negative 5 and 5/7. Okay, I'm trying to go as quick as I can. If you need to rewatch part, you go right ahead. Okay, so we've got a quadratic here, and I'm going to solve it using listening to Sad Me, right? Undo subtraction, addition, undo division, multiplication, and then undo the exponents in that order. Once I do that, then if it's quadratic, I'll actually try to estimate it. So I'm going to add 5 to both sides, and I'm going to get 3x squared equal to 45. I'm going to divide both sides by 3, because I'm doing multiplication before I undo the exponent. X squared equal to 15. I'm going to take the square root of both sides, and I will get that x is equal to plus or minus the square root of 15. Now I know that's going to be pretty close to 16, but I'm still going to go ahead and estimate, pretty close to 4. All right, 9, 10, 11, 12, 13, 14, 15. I found the 2 perfect squares, don't forget 16, that 15 is between. It's between 9 and it is also between 16. So I'm going to take the square roots of these, not every single one of them, but I'm going to use the information I can to help me estimate the square root of 15. Okay, I know that the square root of 16 is plus or minus 4. Square root of 9 is plus or minus 3. Oops, not sure what happened there. Okay, and then I'm going to divide this in half. Looks like there's 8 pieces of data. So this would be, the 12 and a half would be about plus or minus square root of 3.5. I'm going to find the median of the second half of the data, and I'm going to go plus or minus 3.75. So this allows me to say the square root of 15 plus or minus square root of 15 is about, what do you think? I'm probably going to go high 3/8, maybe 3/9. I'm going to go about 3.86 plus or minus. You only have to go to the nearest tenth. So if you said 8 or 9 and you had good work down or a good explanation, I could give you full credit. I'll bet you it's going to be pretty close to that. Let's see if I can figure it out really quick here. Let's see, where is Google? Google. All right, let's see what we're doing. The square root, root of, I am a wonderful typist, by the way, of 15. Nope, not of 25, 15. There we go. And it should come up in a moment. Something's wrong. It's taking too long. There we go. It says 3.87, 3.87 And of course, that's only an estimation. And I guess 3.86. That's pretty good estimating there. Pretty easy to do. Okay, got to get my little thing back on here. Hello, we're not working. Ah, things are running away from me. They don't like me anymore. Okay, so let's try the cubic. Now, we're not going to have to estimate the cubic. So I'll subtract 6 from both sides. And I'm going to get x cubed equals 2, and that's going to equal 21. And of course, I'll multiply both sides by 2, 2 over 1 on the left and 2 on the right, and I'm going to get x cubed equals 42. I'm going to take the cubed root of both sides. Okay, so x is going to equal the cubed root of 42. Now, I know my perfect cubes. I know 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64. It's going to fall somewhere between there. But the little estimating trick I did with the quadratic doesn't work for the cubics. I haven't had time to really sit down and study how to do it. But anyway, so this will be the acceptable answer here. Oops. Sorry, didn't mean to cross that out. All right, let's move right along. Let's see here. Okay, multiplying monomials. Please don't get number 5 wrong. It will not be 6x. It'll be 6x squared. Remember, if you need to put those little ones in there, do that. When I'm multiplying variables, I add the exponents if the bases are the same. When I'm dividing variables, if the bases are the same, I subtract the exponents. And then when I do powers to powers, that's when I multiply the exponents. So in this one here, I'm going to do 3 times 2, and I'm going to get 6. I'm going to get x to the 4th times x to the 1st, which would be x to the 5th. And I'm going to do y to the 1st times y to the 9th. That'll be y to the 10th. And then I've got an 8 and a 12, if you can read my 12 there. And I'm going to get z to the 20th. And there you go. Piece of cake. All right, on this one, I would rewrite the problem as a division problem. 15x to the 4th, y to the 9th, z to the 10th. I'm going to put it over 5x to the 1st, y to the 6th, z to the 8th. Okay, so 5 is going to go into 15 3 times. X is going to go there 3 times. This is going to be y cubed, and this is going to be z squared. And so I'm going to end up with 3x cubed, y cubed, z squared. And that's it. Yeah. Now, sometimes it's a division problem like this, and I've got those negative exponents. Remember, a negative exponent means to use the reciprocal. So I need the reciprocal of this number, of this one, and I think that's it. So I'm going to rewrite this, 36/48. I think 12's going in both of those. Whoa, I'm in highlighter mode. That's no good. Okay, so I'm going to from a fraction, and I believe if I divide by 12, I'm going to get 3/4. Now the x squared is going to the denominator. The x to the fifth, negative fifth, is going to the numerator. The y to the fifths are going to cancel each other out. And here I'm going to have z to the 20th over z to the 22nd. And now I will simplify a little bit further. 3 in the numerator, 4 in the denominator. X to the fifth over x squared would be x cubed in the numerator. Z to the 20th over z to the 22nd will be z squared in the denominator. And there you go. All right, number 9. A negative exponent means to use the reciprocal. So I'm going to rewrite this, taking the reciprocal of 3/5 and then using a positive exponent. Now I'm just going to square everything. 5 squared is 25, 3 squared is 9. Piece of cake. It's too easy. Sometimes we have to do something like 10, and then we're going to have special values for x, y, and z. Well, let's simplify as much as possible here. Looks like 16/24 is going to be 2/3, I believe. I divide them both by 8. This guy here is going to the numerator. So I'm going to have an x to the fifth and an x squared. These guys are switching places. They both have negative exponents, right? And so I'm going to get a y to the sixth over a y cubed. And then I've got z over z squared. And I'll take a second and simplify that a little more. I've got a 2 in the numerator, 3 in the denominator. X's are going to become x to the 7th in the numerator. Y's are going to get me a y cubed in the numerator, right? And the z's are going to give me a plain old z in the denominator. If you want to put the 1 there, it's unnecessary, but you can do it. Okay, so now I'm ready to substitute in. So I'm going to do 2, and notice I'm using parentheses. And then that's going to be the y. And then the denominator, I got a 3. And I've got z, and it's just the first power. So I'm going to substitute in -1, 2, and then -2. Numerator, I've got to do the exponents first, right? And so I'm going to get 2 times -1 to the 7th is -1, and 2 to the 3rd is 8. Denominator, I'm going to get 3 times -2. Okay, I like to simplify first. I'll probably do it your way, but I tell you, I'm going to get I'm going to get 8/3 as my answer. I know it, I can tell, because I'm canceling out these 2's, and I'm canceling out those negatives. 1 times 8 over 3. But I'll do it the long way, because that's how you'll probably do it. I wish you would do it this way. I wish you'd go foom, foom, shoot, shoot. It's much easier. But if you're not ready for it, that's okay. So 2 times 8 is 16 times -1, -16. 3 times -2, -6. This will simplify to a positive. The two negatives will cancel each other out. And if I divide both by 2, I get 8/3. And there you go. Okay, the video is going to be a little bit long, but it is a review video. And I got to check my time here. I only have a minute or two. I think I'm going to pause right now. Okay, hope there wasn't a break in the continuity. It's been several hours. If you look at the clock, since I recorded, I got interrupted. I had to teach, but no problem. So I'm going to do problem number 11 here. And I'm going to first simplify inside the numerator, or excuse me, inside the quantity as much as possible. And I notice I have a negative exponent there and a negative exponent there. And I also notice I have a negative exponent out here. Going to take care of the yellow ones, simplify as much as possible inside, and then I will take care of the blue one. So 10/12 is the same as 5/6. X squared, x to the 6 over x to the 4th is the same as x squared in the numerator. Y to the 4th over y to the 6th will be a y squared in the denominator. The z's are going to switch places. They're going to move. They're going to use the stairs. And then I have a -2. I can simplify a little bit more on the inside. 5x squared, 6y squared. Now I'm going to have a z to the 4th in the numerator. I've got this -2 I need to deal with. A negative exponent means to use the reciprocal, and so I will do this. I will do 6y squared over 5x squared z to the fourth, and then it'll be a positive 2. One last step, I have to square everything. 6 squared is 36. Y squared squared is y to the fourth. 5 squared is 25. X squared squared, x to the fourth. And z to the fourth squared, z to the eighth. And there you go. All right, down to the last section, rational exponents. Remember that the denominator means the root of, right? And I always suggest taking the root first. So if I think about 81, the fourth root of 81, well, isn't that going to be 3? 3 times 3 times 3 times 3 is 81. So what I have is, I have 81, and I'll write it like this, the fourth root of 81, and then I'm going to raise that answer to the fifth power. So I know the fourth root of 81 is 3, and I got to do 3 to the fifth. Now I'm going to work smart. I'm not going to go 3 times 3 times 3 times 3. I know that 3 to the fourth is 81. So 3 to the fifth must be 81 times 3. Or in other words, 3 to the fifth is going to be 243. And there is your answer for this problem. Okay. All right. So now this one here, I could do the third root of negative 8, which would be negative 2, and then raise it to the negative 6th power, which would be the same as the negative 1/2 raised to the 6th power, right? I use the reciprocal. And then that would be the same as a positive 1 over 64. That would be the hard way to do it. Check this out. It's a good way to do it, but it's more difficult. I can simplify this fraction. This problem is really negative 8 to the negative 2nd power. This negative exponent means to use the reciprocal. I'll have negative 1/8 to the 2nd power. Negative times a negative is a positive of 1 over 64. Look, I get the same exact answer. All right, this one here, if you were listening to Bradley on Friday when he had such a great class, this is going to be the same as 25 to the 3/2 power. Okay, well that means I could take the square root of 25. So I'm going to get plus or minus 5, and then I have to cube it. My answer will be plus or minus 125. Oh, and I made a mistake back here, didn't I? Yeah, because the fourth root of 81 is going to be plus or minus 3, so the answer is going to be plus or minus 243. I apologize. I'm going a little too fast for my own good. There you go. All right, this one is cake, 15. I'm asking myself, what do I have to multiply by 1/5 to turn it into 1, right? Because I want it to be x to the first power. Well, geez, just let's multiply by 5 on both sides. The 5's will cancel. Y times 1 will be y. Right-hand side, 5. Y is 5. Of course it is. X to the 1/5 raised to the 5th power is the same as x to the 5 times 1/5, which is the same as x to the first. And there you go. So y equals 5 is the answer. All right, that's the video, ladies and gentlemen. Good luck on your test. I'll see you Monday. Bye-bye.